Hello. So I've got this really nice Heathkit Hero Jr. robot from the 1980s or so, which is fully functional and fully upgraded with 24 kilobytes of RAM. Not that I will ever need that much RAM for it. As well as a serial port and a really nice from Robytes, which includes all the cartridges produced for the Hero Jr., including the all essential basic cartridge. Um, the problem I have with this robot is that anytime I want to program it or play with it, I have to physically connect it to a serial terminal in order to access it. Now, I can play with it using some of the pre-programmed performances using the keypad, or I can just use the remote control for basic movement. But that's not really programming, that's just, you know, toy functions, which I'm not really that interested in. I'm far more interested in getting this robot to do interesting things. After a little bit of research, I came up with a solution. The issue we have with the Heathkit Hero Jr. robot is that its serial port only uses 7 data bits, not 8, which is currently the standard. And it uses even parity, not null parity. There is already a module called the XB wireless module, which allows you to connect to serial ports wirelessly. Unfortunately, it does not support 7 data bits, only 8 data bits. And it's quite expensive actually once you add on the carrier boards, etc. That did not work. After some research, I did come across, however, on the internet, this cute little device. It's called an HC12 wireless module, which is under $5 on eBay. I mean, it cannot be cheaper than that. It includes a coil antenna, and it has over here ports basically for 5-volt power, ground, the transmit and receive lines, and a set line to program the module for the functions you need. This module will accept any baud rate and any type of communication configuration, including the all-important 7 data bits and even parity that I need. And for the price, it was really, really attractive. Thing is, though, I mean, you can program it using an Arduino by accessing the RX and TX ports directly. However, if you want to connect it to a serial terminal, then you have to use a serial to GPIO converter, which will connect to the TX and RX pins on the HC12 and convert the signals to RS-232 compatible levels, which then can be connected to a serial terminal. So you'll need really these two devices. Again, these devices here, the serial to GPIO converters, are under $10 on Amazon or eBay. And so combined with the HC12, you're still way under the price of a single XB module. So I went ahead and bought 2 of those, all you have to do is basically solder a header and solder the antenna that comes with it, and you're set to go. So for the side of the Hero Jr. robot, I created this very simple board. Essentially, I have a 12-volt input coming from the battery of the Hero Jr. I did not want to have a separate battery for this circuit, so we'll take some voltage away from the robot, which is pretty minimal really. We're talking here under 20 milliamps at most. And I'm using a 7805 voltage regulator to drop the voltage from 12 volt to 5 volts with a little heat sink. And that supplies the 5 volts needed for the serial to GPIO converter and the HC12. I'm connecting RX to RX and TX to TX on the HC12 and the serial to GPIO converter. No null modem needed at this point, and this gets connected to the serial port of the Hero Jr. On the receiving end, I also created a small separate board as well. This one will connect essentially to the terminal and will be powered separately, likely with about 3 AA batteries or something like that, and should work just fine. And essentially same setup. It's a HC12 and a serial to GPIO converter with the TX and RX lines connected together, and the power is shared between the two modules. So here we are. I have the wireless board for the Hero Jr. side connected. I've got the serial port here going to the back of the robot, and I've run a 12 volt power line from the battery, which is behind this panel here, to the board. My primary concern here is not to damage or modify the robot in any way. I really like to keep it in pristine condition and in original functional condition. So I did not drill any holes, I just ran a line from the battery. So on the receiving end, I'm using this period compatible Heathkit H19 terminal, just to keep the Heathkit theme going here. I love this terminal, by the way. It's really fun to use. And I've got the receiver module over here, and it's connected via serial cable to the back of the terminal and powered externally by a 5 volt power supply. So at this point we're going to go ahead and run the test. Basically what I'm going to do is I'm going to go ahead and power up the robot and reset it.
Ready.
There we are. And at this point I'll do a cold start for basic, and it should send a prompt to the terminal saying that it is ready. So press 1, and if we go back to the terminal, we will see that we've got the prompt here. Heathkit Hero Jr. Basic version 0.1. Apparently they did not go beyond 0.1. It's a really lousy basic, by the way. It's extremely primitive and really not very useful for robotics at all. So I've got some ideas about that, but basically it works. We're not connected physically to the robot here. This is all wirelessly. And if I go ahead and say, let's have the robot speak. Let's see, let's say, where is it? Hello? And now, if I press enter, the robot should say hello.
Hello.
There you go. So, this is not the end of this project, though. I mean, the idea is for me to be able to control the robot remotely using another computer, a vintage computer, as the actual brains, given that the Hero Jr. Basic is so primitive. And having the Hero Jr. essentially just as a dumb terminal, in a sense, or dumb robot. It'll execute commands and it'll send information using its sensors back and forth. But all the decision making and actions will be commanded by the remote computer. So I'll have a demo about this hopefully soon. But this is where we are at this point. Thanks for watching.